Hello everyone. This is your instructor Dr. Ekeeda Mishra speaking to you. So today this is our software engineering class and we will be discussing on the analysis models, and we will be basically focusing on two specific models, which are the class based and the flow oriented models. Just 1 minute. So today the topics that we will be covering, we will take a look at the previous classes because we didn't have the last 2 weeks, and we will look into the analysis and the design approaches. What are the different types, what type of questions can come in that, and we will also discuss some of the examples and problems that we will have in class-based modeling and the flow-oriented modeling. So we will be covering all these type of items under the class-based modeling. And similarly, under the flow-oriented modeling, we will be dealing with this data flow diagram, data dictionary, decision tables, decision tree, and so on and so forth. So we'll go by one. So if you remember, this is a diagram which I had shown you in one of the earlier classes. So I don't know how many of you remember what is this diagram. Who can say that? Well, this is the process diagram. This is the process model that we considered, and this is the generic model. We had seen the generic model. The process model basically tells you the process flow, the way we will be organizing our activities in the project, in the software project. So this is what we had said is a generic process that we can apply to each and everyone. And we had said that these are the activities that we are doing. And as you can see, analysis, modeling, under the modeling, we have analysis. So modeling is a very important part of both the analysis and the design in a software development project. This was another view of the process model. This is a waterfall model in which we had said that we had named these activities in line with what is the actual activity we are doing, what is the software activity that we are doing. So if you see, after the feasibility study, we have the analysis specification of the requirements. So in one of the previous classes, we had gone into the requirement analysis and we had discussed this. So let me see, what is this? Which are the SE activity, these steps to be followed? Inception, elicitation, elaboration, negotiation, specification, validation, and management. So what are these? What are these? These are actually the steps for the requirements engineering. So if you see in the previous one, we had requirements engineering as one of the major activities of the software engineering. And in that process, in the software engineering process model, and under it we said there are 7 types of activities. And what are the actions that we are carrying out in each step? In the inception, we are looking into the setting up of the collaboration with the customer, doing the initial actions. Elicitation, we are gathering, because elicitation means collection or gathering. So we are getting the requirements and we are making some models, and then we are coming to the elaboration. Elaboration means analyzing, understanding more, getting into the root of these things. And then after that only we can finalize the requirements by doing the negotiation, specification and the final validation. And once this is done, we start the design and the other activities, and then we keep on managing the requirements. So when you do this, what model is done during requirement elicitation? When we had done requirement elicitation, if you remember, the answer to this question is use case. We had discussed the use case because in the beginning we have to see the user's view of the system, what they want to do. So that is how we will gather the requirements. And the use case, we had the model, we took the initial context, and then we created more and more. We broke it down into lower levels, into detail level use cases, and we did the use case packaging also in the previous classes. So now what we are going to deal with requirement analysis. What kind of models do we create in the requirement analysis? What is their importance? How we will do it? And what is their benefits? These are the kind of things that is the question that may come in your exams or in your interviews. So we will look at those in terms of those questions. So why requirement analysis? Why do we have to do the requirement analysis? Because we have to do the elaboration on the basic requirements that is established during the inception and the elicitation. So in the elicitation, whatever use case we have done, we have to go into the in details of this. We have to elaborate it, and we have to build the models that will depict the user scenarios and also the functional activities, the informational problem classes. So we have to find out what are the classes. I think all of you are software computer science students, so you know what is class because we have been doing object-oriented programming. So that is the class and objects that we are talking of here. Problem classes, not the implementation classes that you write in your program, but problem classes as seen by the user. Their relationships, their system and the class behavior, how do they behave, what happens when certain event comes, and the flow of data. So all these things that we have to elaborate, and when we elaborate all these things about the requirement, we will build models into it. That is why we say analysis models. And it is a part of the requirement engineering. As such, throughout the analysis modeling, the focus is on what to build. So because we still are talking of what to build, we are in the requirements engineering. So requirement analysis is part of requirement engineering, where we are specifying in detail what to build. And what is the outcome? Outcome of this is the operational characteristics of the software, how it interfaces with other system elements, what are the constraints. So if you get such kind of questions, you can answer this way. And what are the analysis model objectives? What are we trying to get out of this analysis models? So what we have to do, the primary objective is threefold. One is describing what the customer requires, establish a basis for the creation of the software design, because so far we have only got use cases or some description of the problem. With the description of the problem or just use cases, we cannot do a design, because design will involve much more understanding. So when you have these analysis models, when you have created the analysis model, then you can create a basis how these analysis models will get translated to your design models and your code. So it forms a basis, defines a set of requirements that can be validated. So once you have this, then once you have these models, against these models, you can create test cases, so that when you have completed the software, you have already built it, then you can validate it. That means you can test it. So what will happen? The analysis model is still the user's view, and the user's view, the functionality of the user's view, and the how aspect, that is the technical view that the designers and the programmers need. So this analysis model will create a bridge. It will bridge that gap between these two, the way the users speak and the way the technical programmers speak. And analysis models are prepared as part of the requirement. And they are directly traceable to the software design element. So these are the primary objectives, and these are the additional objectives of the making the analysis model. So what are the operational principles? Is there a principle by which we will do this analysis? First of all, we have to do the information domain. That is the first and foremost principle. So whatever is our problem, we have to represent the information domain. That means what kind of data will get in and what kind of data will go out, what kind of data will have to be stored into the system. And what is the functions that the software must perform? What is its capability? That how it will benefit the end user in doing their business. And the behavior of the software must be represented. So we have to represent the information domain, we have to represent the functional domain, and we have to represent the behavior of the software in this analysis modeling. So these are the three principles, operational principles of analysis modeling. And if you go to the strategy, what is the strategy that we apply in the analysis model? If you take that as a question, then we have to do the partitioning. That means we have to take the bigger problem and break it down to smaller and smaller problems, divide complex problems into sub-problems until each sub-problem can be understood easily and it can be converted into your design and the program. Now let's look at what are the major elements of analysis modeling. Because when we say analysis modeling, then there has to be some, what are those, what does it consist of? The question you can say, what does it consist of, analysis modeling? Okay, so there are 4 types of modeling. There are 4 types of elements. That is the first thing. There are flow-oriented elements, behavioral elements, class-based elements, and scenario-based elements. Normally, these flow-oriented elements are describe the information domain. Behavioral domains will describe the behavior of the software or the requirements. Class-based elements will give you the function and as well as some part of the information, because you know object-oriented, they contain both. And then this is the scenario-based elements, which are the user view. And under each view, under each element, we have a set of tools or a set of diagrams or a set of models. So these are all the models. These models can be either in the form of a tool or in the form of a diagram or in the form of some text, some method. So you have data flow diagram, data dictionary, control flow diagram, control specification. So you can remember, suppose somebody asks you, what are the flow oriented elements? So you should be remembering that, okay, under the flow oriented elements, I have to say what is a data flow diagram. I have to say what is a data dictionary, what is process narratives, how can you have a control flow diagram. So this is how you can get a question. Similarly, you can have a question on behavioral elements. And you can have a question about explaining each of these or giving example of this. So we will look into those aspects. So what are the major approaches? So do we have only one approach or do we have more different approaches? So there are basically 2 major approaches. One is called the structured analysis. The other one is called the object-oriented analysis. This structured analysis is more of a classical method that used to be applied before object-oriented paradigm came into the software engineering. Only when object-oriented programs started, compilers started, programs started, saying like C, C++. From C, C++ was born, and then Java, Ruby, and many other, Python, and many other object-oriented programming languages came up. Then people started thinking in the terms of object orientation, and that is how the object-oriented analysis approach started coming. Before that, we had the structured analysis, which had data objects, where we were modeling the data objects, their attributes, their relationship, the processes that are used to transform the data into information that will flow into the system and provide the output. And it is also sometimes referred as function oriented because it depends on how the customer is performing the function, what data it is taking and what process he is using. Whereas in the object oriented analysis, we focus on the objects and the classes, their relationship, their collaboration to satisfy a user's function. Again, the function is the main word, but for doing that, we are trying to create the class. And as you know, the class will hide the data inside it. So we don't have to deal with the data separately. And the UML, Unified Modeling Language, is a very good tool or a language which supports the object-oriented approach. The major difference in the structure analysis, so this is a very important question that will be asked in the exam. What is the difference between structured analysis and object-oriented analysis? So in the structured analysis, the data and processes are separately modeled. We have said that the data will be modeled and then processes will be modeled. But in the object-oriented approach, data and the process are together as part of the class-based model. So in OO approach, we will go for class-based models. So extracting this, there is another question which is SSID and OOAD. What is SSID? Structured System Analysis and Design, or SSID. The other one is an extension of the object-oriented approach, which is the object-oriented analysis and the design. So you have this object-oriented and you have the structured analysis. Which one is the preferred approach? Currently, OOAD is the preferred approach. Why is the OOAD the preferred approach? This is what is the question that will be asked. Why is it that OOAD is a preferred approach? When there is a classical method, why can't we do that? So one of the major thing is that it allows a lot of reuse. So this is the major focus in the OOAD. So our effort will be less. Objects can be mapped to real life objects. So you can even ask the user to identify classes, objects for them, and then you can start the analysis. And it is easy to understand by both user and the development team. Unlike in this SSID, they had a different approach and developer had to transform it. Here, both will understand what is an object and what is a class. And agile processes and automated tools are there for the OO approach. A lot of support is there. So that is one advantage. And UML standards can be used. So it is more standardized. So OOAD is preferred because of code use and because it is more like real life. It is understandable. It supports the communication is better, and also you have a lot of support. So what are the kind of models we will use? If you have the structured analysis, when you have the structured analysis, you will use the use case diagram, and you will use the use case. So those part is the common part, and here you will use the activity swimlane, that is also same. And the top part is the users is the scenarios. So this part is the scenarios, the top part, they are the scenarios, these, and this part is different because here you have the data flow, the information flow, process narratives, and here you have the class-based approach. So these things will come, and then you will have a control specification, all control information will come here, and here you will have the sequence diagrams. These are some of the behavioral diagrams will come here, and the similar behavioral diagrams here are control specification and state diagrams. So what are the different activities in class-based modeling? So now we'll go to the class-based modeling. What are the different activities? We have to first identify the analysis classes. This is the first and foremost activity. Then we have to specify its attributes. We have to define its operation. And you know this because when you write a class, when you define your class in your program, you have to give a name. But before knowing that, you have to determine what is the class I have to do. So identification is the most important part. This is the most important part in the analysis. Only after you have identified, you can go and design it and code it. And then not only that we will identify the classes, we need to know the relation and the collaboration. So we have to create the class diagram and also a diagrams that will determine the relationship between the classes. So how to identify the analysis classes? There are basically two approaches. The first approach is called the grammatical parse. This is a very old method. What do? We take the problem statement and or the use case descriptions or any narrative that we have regarding the functionality or the processing of the system, how the function is working. And we take that during the requirement elicitation, during the use case descriptions, we have already collected it. And we do what is known as a grammatical analysis on it, grammatical parsing on it, or grammatical analysis on it. And what does it mean? Basically, it means that we are going to look at the nouns and the verbs. So that is why it is also called a noun verb method. So instead of calling it a grammatical part, sometimes we try to identify all the nouns which will form the objects and all the verbs which will say what it is doing, what is the operation on it. And once we know it, those will become the potential classes. The nouns along with its verb will become the potential classes. From these potential classes, we will try to create the analysis classes, the final analysis classes. And using the class responsibility collaboration, this is another method. It is called in short CRC. So in the CRC method, what is done is it's a team collaborative effort. That means both the user and the programmers will have to sit together, or the analysts, and they will identify the domain related classes. What are the problem related classes? In the problem domain, what are the classes? That means who are the doing people? What are the objects that they look into, for which they will like to store something, and for which there will be some action, some responsibility will be there. These classes will do some responsibility. They will be responsible for doing some action, some methods they will have. We don't call it methods. Methods is normally called when you go to your implementation, but here we call it operations. At the time of doing the analysis and the design, we don't call it method, we call it operation. Finally, an operation of a class will be implemented as a method in your coding. So once we do the analysis classes, then we can do from there we can determine the design classes in the design phase. So how do analysis classes manifest? When we read this, whenever we do the CRC method or when we do the grammatical method, we need to have some idea how these classes manifest themselves in the real life. So because we said that classes are more like real life. So how do they manifest? Sometimes they manifest like external entities, and sometimes they manifest like things, events, some occurrence is happening, something is coming, some information is coming. So that becomes a class because it's a behavior. Some of the roles, managers, engineers, salesperson. So those roles are there. Things are objects. They are not persons. They are objects. But when you have roles, they are normally persons. But they are not identified by them. They are by their name, but by their category: engineer, salesperson, manager. So that's why they say it's a role that they are playing. Organizational units. There can be organization divisions, sections, groups, teams, class, departments, and then there will be places, workplaces, or cities, or production floors, buildings, things like that, or seminar halls, things like that. Then there will be structures. So what is structures? We normally talk of data structures, but here we are talking of physical structures. So we have vehicles, buildings, sensors. So what are these? They are conglomerate. They contain multiple things inside it. So that is why we call it as a structure. So they are physical structures because we are all doing in the problem domain. So these are the different ways that classes can manifest: external entities, things, events, roles, organizational units, places, and structures. And what do we do when we do the potential class by the grammatical processing? So this is an example. So these are the parts of the speech. When we read the description, you can have a proper noun, you can have a common noun, you can have a verb or a doing word, being verb. So there can be different types of operation, different types of verbs, having verb. So you can have a doing verb, you can have a having verb and a being verb. So here you know that the model component is an operation, but here it could be inheritance. Here it could be a relation. So these two are relations: inheritance and aggregation composition. So this is a generalization and inheritance. So here examples are, when you read it, you will have something is a kind of something, or is one of the either. When you have aggregation, you can say has, consist of, can say a page consists of many words, or a book consists of many pages. So there you know that it is aggregation and composition. Then you will have modal verbs. This is another type of verb. Then you know that it must be a constant. So that is on this class, there is a constant. So this defines a constant to a particular class. Then you will have adjectives. Adjectives normally help you in identifying attributes or the properties of the particular class. So these nouns, proper nouns and common nouns becomes objects or class are there either or they are attributes. So what we have to do, we have to basically map them. So what is the parts of the speech we will have to see in the grammatical parsing. We'll take each sentence, we will divide it into parts of the speech, and then we will map it into object model. So these are the object model components, all this part, and we are going to map it like this. So this is the example. And once we have created the potential classes, is there any method by which we can select which are the actual classes and which are not the actual class? Can we merge them? Can we eliminate them? Can we select only a few of these? Because initially, if you take a page of a process narrative, then there will be, you may get 100 potential classes, but all that may not be required in your system. So you will have to simplify it. So you have to look for retained information, needed service, multiple attributes, common attributes. So you have to use this kind of criteria. I don't know whether this will ever be a question, but it is good to know. So these are one of the major things. So you will find that multiple times you have taken a particular noun, but all the nouns are having common attributes. Then you can merge it and give a single name. Similarly, if you have multiple attributes, then this is a potential class, because this definitely has a lot of information, a lot of data inside it. So then you can select it. So these are methods where you select it. Does it need a service? That means is it providing a service? That means can we identify an operation over this class? Then definitely this class needs to be there. And again, some retained information, that means we need to retain it in the system. Then we need to consider that as a potential class. So by doing this, you can eliminate that. Somewhere you will not get these kind of criteria for the potential classes. So you can eliminate those potential classes and select only those that are left out as the analysis class. So now we come to the distribution. What is attributes and operation? I think I don't need to elaborate it much. All of you know the answer. Only thing, as I told you, attributes all of you understand. These are the properties, set of data objects that fully define the class, and it belongs. It just tells you what are those things that belong to the class, the internal information or the internal data. Operations is what we say when we do the class analysis or we identify the class. Later on, when we go to the implementation phase, we call it as methods. So operations that manipulate data, operations that perform computation, operations that ask about a state of an object, monitor an object. So they tell you the behavior of that agent, what exactly it is doing, what is its responsibility, what is the responsibility of the class. That is basically the operations. So to derive the set of operations, analysts study the use case, and from the use case and the what you have done earlier, you can map them and determine the operation. So it needs a little bit of practice. You have to take some case studies and do it. So now we come to the second method. So till now we were looking into the characteristics of the grammatical parsing for identifying the class. Now we are coming to the CRC. What is CRC? What is class responsibility collaboration modeling? Can you explain it with the process, and can you give an example to it? So here, as we said it is a collaborative, it's a team effort by both the customer and the analysts. And what they do is they try to identify some standard, there is a index cards. So they take a set of index cards and they start creating the CRC models into it. So each card will have three parts: top part, body part, and the end part. Body part will also have the responsibility on the left side and the right side. So the body part will have two parts, two sides. On the left side you will have responsibility, on the right side you will have collaborators. And the top part will be the identification, the class name. And that's what I said, it is created as a team effort with the stakeholder or the clients. And you can either have it physical or you can have it in electronic form. Class denotes the grouping of similar objects. Objects are instantiation of a class. This all you already know about it. Gives a means of identifying and organizing the classes that are relevant to the system or the product. So here we don't have to first determine the potential classes and then go. We can directly go to the classes from the CRC cards. So what we have to do, responsibility is something that the class knows or does it, and collaboration is something that the class needs to do, but it doesn't have the information. It has to go to some other class and get it. So collaboration represents a request from one object to another object to fulfill it. Like what we do in our class implementation, we send a message and we try to do a operation of another object. So one object collaborates with another object if it needs to send some message or information to other object to use its operation. So that is a very simple case of a collaboration. Collaboration can also identify some relation, determining whether a class can fulfill its responsibility. If it cannot fulfill its responsibility by itself, if it doesn't own the operation, then it has to interact with another class. So that is where we have collaborations. So we can see an example. This is the floor plan. There will be a deck of cards. So that's why I have shown the deck. And this is a single one. As you can see, this is the floor plan. This is the class name. And then there can be some description here, which is omitted. And this is the left part, which is the responsibility. Then we have the right part, which is the collaborator. And what does it do? These are all the operations that it has to, either they will become part of the attributes, or they will become part of the operations. Defines for plan, manages for plan, scales for plans. You can see they are less like methods. And then it incorporates walls, doors and windows. So now walls, doors and windows can be independent because they are too small, and this floor plan is something much higher. It's an aggregate of so many things. So you can have the wall as a separate one. So when you incorporate some of the properties or the operations of these things, then you have to collaborate with the wall, with the windows, and like that. Similarly, it shows position of video cameras, and video cameras are not part of the floor plan. So you can have the camera separately and you can call the operations. This is another one. You can see This is more like our situation in the education. We have a course section. So responsibilities are display course section menu, hide course section menu. So if you are asked the question like create a CRC card for display of course for a section, then you can create a CRC card like this. So this is the description part. This is the name part, and this is the responsibility part. Display the course section menu, hide course section menu, enable it, disable it, get the course, create new course, update. So these are all the functions that it has to do, all the operation that it has to do. But for doing this, it needs to possibly collaborate with other classes, independent classes, which are course and grade. So what are the different ways classes can collaborate? So now we have seen the two methods. So we have answered all the questions in that. And how many types of class? Now we will go to the class relation. What are the collaborations and the relations between classes? So I don't know if whether you are aware of it. You might have read it in some of your object-oriented classes. We have majorly three generic types of relations. One is called is part of, another is called a has or has knowledge, and the third one is the dependency or use or is a kind of. So these are the three types of relations, and this dependency can be of various types. So we'll look at today generally. But if you somebody asks you how many types of class relations exist, you can immediately answer this, and you can give some example of this. So normally whenever these questions are asked, you are asked to give an example, or somebody will give you this chassis and doors and ask you what kind of relation it is. So when chassis and doors, these are all parts of the car. So definitely this is a relation or a part relation. So it is defining an aggregate class. So which is the aggregate class? Car is the aggregate class, and these are the parts. Similarly, country and its capital city. There is just a association. So every country is aware that it has a capital. So it has. So the relation is has. And when you have this kind of thing, then you can have a we'll see this. There are different types of dependency here. So this is an example of a class which is already implemented. This is a class which is in the UML notation. So the question is here, class diagram, how you denote it, and can you illustrate it with an example? So here we are illustrating. We are taking a very simple class called employee, and we have given its attributes. So it has got three parts: the identifier, that is the class name, the attribute part, and the operation part. And in each one, we are giving the modifiers. So we are telling whether it is this attribute is public or it is private or it is protected as static. And similarly here we are telling what is the type of the method, whether it's a string or a character or binary or whatever it is. And how many, here we are also telling how many inputs are there. And for each input we are also telling the type. So the typecast is there for the operations. So there are abstract classes, you know that. How are class relations depicted in UML? So we provide some kind of lines, but there is some notation about the lines, how you will write. If you want to give association, that is has a kind of relation, then you have to denote it by a straight line or an arrow. And if you have an aggregation, that is a part and a whole, then you have to put an empty diamond on one side. If you had in the collection side, in the group side, you will have the diamond. And if you have composition, then this diamond will become a solid diamond. And here it is much stronger. And in the generalization and inheritance, that is the last type of relation, we show it as a triangle pointing to the superclass, because this is normally the is a kind of the last type of relation, which is the dependency. We called it dependency, depends on. Okay, so here you have the superior class, superclass, and the subclass kind of relation, or what is known as the generalization. That means many objects, the lower objects get generalized to a higher class, and the lower classes inherit the properties and the operations of the superclass. So there is a superclass subclass kind of relation. For example, bird and reptiles are part of animal classes. So you can provide these examples. This is the notation that we talked of. This is the normal, or you can have an arrow like this, and you can have a triangle. And you have the triangle, you have generalization or realization. This is in the realization, that means this is in the object. This is for the class. And you have the dependency. It's normal dependency, which is not generalization or relation, but other kind of dependency, maybe some constraint or something like that. This is the aggregation and composition. And this is the other kind of knowledge kind of association. So this is the given example of association. So you can take a student and a course, and you can determine this. And you can see this. Okay, a general binary relationship between classes can be ternary. Ternary means it is a complex association. So either you can put an arrow here, or you can put an arrow here. An arrow may be attached to the end of the path to indicate that navigation is supported in that direction. If it is omitted, then it is allowed on both directions. Okay. You have examples of multiplicity in association. What is multiplicity? That means you are trying to say how many of these classes are related to this class. So if you say that minimum 6 or more will have enrolled to one course, then you can write like this. And similarly, one faculty can teach more than one. So star denotes that it can be multiple. So this gives you the multiplicity. One here it is a single, but here it is multiple. And here it is student, one student, some set of students will be advisor, one faculty will be advisor to them, so, or a mentor to them. So here we start with 0, because some faculty may not have any, may not be advising any student. Only few faculties may be student advisors. But whereas here, every course must have a minimum strength. So that is why the 6 is written. So this is the notation that you use for it. So you can, you have to remember this, how you denote. This is an example of complex association. So we said complex associations, that means not only everything is not binary, but we will have ternary or higher. So ternary means there are multiple classes which are associated together. So these are some of the examples. So give examples of complex associations. You can give examples. There's a project, language, and programmer. And this is how we will denote it. One programmer is working on multiple projects, and each project is using a language, and each programmer has known some languages. So if you instantiate this particular relation here, for this class you will get an instance idea. So P1 is a project, P2 is a project, Joe is a programmer. He might be working on 2, and this particular project uses C. This particular project uses Java. So that is how you can create a class diagram, and you can instantiate it with the objects, and you can verify, or you can create the object diagram and then generalize it to the class diagram. And this is a recursive one. This is another complex one. So if you have a relation, like you have an employee, and also you have a manager. So a manager is also an employee, but a lot of employees will be under the manager, but the manager himself is also an employee. So you will have this kind of recursive relation. And this is another one, A, B. So when you have this will do something. So they will use this is a simple binary association. So this is instantiated, my A, and it will do something. And this will be by. So these are, so B is usually using the this operation. This is you are instantiating my A, and you are doing something inside under B. How to depict aggregation and composition in UML? We have said that we will use the diamond for aggregate, and we will use a filled up diamond for the composition. So this is what is the difference? The difference is that this is a stronger form. This is a lifetime. When you have composition, it's a stronger form. It's a lifetime. It doesn't get out. It always is there. It has the bigger class has got complete ownership of the component. It cannot be separated. Whereas here it doesn't have that. It can be removed. A part can be removed from the whole. A body chassis can be removed. The car door can be removed. These are some of the examples. So you can try to take some of these examples. The team is there, an employee is there. So this is how it is implemented. Okay. Similarly, a crate and a module. So here also it is doing something. It's so here it is a hollow. So this is a aggregation, whereas here it is a composition. Show class relation between university, college, and student. This is an example that I wrote for you. So this will be the question. Show class relation between the university, college, and the students enrolled in a department. So there will be a little bit more description maybe there. So you know that university, this is the organization. This is also organization. Students are roles, and department is another organizational name. So you have immediately able to identify the classes. So you will have one class called university, one class called college, department, student. Then something is not written here, but then if they are there, so definitely some faculty also has to be there. So like that you will identify hidden classes, and then you start making the relation between them. So always a college will be part of a university. So this will become a hard diamond. So this is a composition, whereas student belonging to a department is a aggregation, because student can change the department, and student will take courses in different departments. So that is why this is a hollow one. Similarly, faculty and department, they can be taking different classes in different departments. They can be member of multiple departments also. Faculty may be common. So similarly, dependency. So the previous one was class relation between this. We were dealing with aggregation and composition. And now the same question may be asked about dependency. So how is dependency depicted in UML? So if that question is asked, then you have to give some examples. So whenever normally the most common example that we do in dependency is the generalization and the specialization. So either we will show that a class 1 is using the other class, or we will show it as a generalization and specialization. That means this is the superclass and these are the subclasses. So here your relation will be a kind of inheritance. So if you have a customer, then you can have a corporate customer, you can have other private customers. Common form of dependency is the use relation among the classes. So if you want to have you can have a implementation in the dependency relation. So you can have a base class, you can have a derived class. So this is how you derive the class in your Java or your C++, and then this is the class B extends A. So this is how you are implementing it. So the standard concept of inheritance that you have studied in your programming class. But what you have to appreciate here is that you do this implementation much later. We are only at the requirements stage. So we are doing the modeling, we are doing the analysis modeling. So when you do the analysis modeling, you create these kind of things. Much later, you are going to do the implementing it in your code. Now we come to the flow-oriented modeling. So we have completed the some of the aspects of the object-oriented modeling. So now we will come to the flow-oriented modeling. So we have completed the class modeling. So now we come to the flow-oriented modeling. Under this flow-oriented modeling, what are the components? What are the elements of it? So we have a data flow diagram. We have a data dictionary. We have the decision table, decision tree, process narratives, and some other things which are giving the behavioral things like the control flow model and the control specification. So what is the principle of the data flow diagram? Or sometimes it is also called as the bubble diagram. Some people will ask you question as a bubble diagram instead of a data flow diagram. But data flow diagram is a more standard nomenclature. So what is the principle? It will enable the engineer to develop the model of the information domain and the function domain. So this is what is the principle, that by using the data flow, you have to create the information domain and the function domain diagram and together. That means in a single diagram, you will show the information, you will show the data and its flow as it moves from process to process. So the function will be denoted by processes and the information domain will be processes, it will be denoted by the data flow. DFD in each function is shown as a processing station. So that's why we will use a bubble or a round or an ellipse like this to know a processing station. And it will consume some data. Some data will come inside it. It will get processed here and it will produce some data. So there is a data flow. That is why we call it as a data flow, indicated by an ellipse or a bubble. Data flow diagram may be used diagrammatically represent systems at different levels of abstraction. That means we will have a higher level of abstraction where we will not denote any detail, and then we will go on detailing it. That means we will partition it. We will go into more and more detail as when we do the functional decomposition of the system. That means we will define lower levels of processes and lower levels of data. A DFT refinement. So what are the different DFT guidelines? DFT refinement results in corresponding refinement of data as it moves. So that's fine. We have already discussed it. So are there any DFT guidelines? Can you create a guideline how to create this DFT? So what we have to say is that always we will have a zero level, because we said it has different abstract levels of abstraction. So at the top level we will have a zero level, which we will call it as a context diagram. So we will try to denote our whole system as a single bubble. Okay, and all other system boundaries. So this will define the system boundaries. Everything is inside is internal, and all outside are external entities. Those will be interacting with the system, and some of it will be going out also, because it will produce some reports. It will produce some outputs. So there will be some entities here who will be interacting with the system. So it will define the system boundary. Then we will have a lower level, refine it to the next level. So from each one we will break it into multiple bubbles like that. So when you say what are the DFT guidelines, you have to write this kind of method. So whenever you come, you will have to take this bubble and make it into 3 bubbles. Again, take each of this single bubble and divide it into multiple bubbles like that. So only one bubble should be refined at a time. Add data stores as the internal. So whatever was internal, now you have to add some data stores. So not only that there will be arrows going out, coming and in, but also some data store will be there, which will have the persistent data, the data that you need to store as a part of the system into your databases or into your file systems. So all arrows and bubbles should be labeled. So there should be name here everywhere, and there should be arrows, proper arrows, not just lines. And these labels should be The both processes should be, these should be labeled, and these arrows should be labeled, and bubbles should be numbered. Not only that, they will be named. So you can put it as a 0 level, you can put it as 1.1 and 1.2, 1.3, and here, so then from 1.1 you will get 1.1, 1.2, like that. So you can know which level you have gone. A DFT must be balanced between levels, that for all inputs. So that means any input coming here, when some input is there, and that should be also available in this one, also in this one. So you have to see that anything that is going out of this, and suppose it is entering here, then when you are describing this one, it should be available. So we'll see some examples, it will be clearer. So let's take this example. So the question is now, draw the DFT of a root mean square software. What is root mean square software? Let's say you are going to design a software which will take few numbers, let's say 2 to 3 numbers, and it will store them, and it will compute the root mean square and give you the result. So this is the 0 level. At the 0 level, which we call it as a context diagram. Okay, this context diagram. You have data, you have the user, he is the external, and he is giving the input is the data item that he is giving, and he is getting the result. The result is the RMS, root mean square, of these data items. Okay, that means you square it and you determine the root, add it and determine the root. So if you want to break this one into the next level of DFT, then you will have multiple bubbles. So initially you will have to read the number, the data items have to go. So I told you that there will be balancing. So any data that is coming in must be also available here. So data items are going in, so read the numbers. This is the first one, 0.1. Then these numbers will come, then these numbers have to be validated. Because whatever we are reading, they may not be numbers, there may be some alphabetic character also. Okay, or if there is maybe range, or there may be negative also. So negative numbers will be difficult. So again, so we have to validate this. After validating, there may be some error, or it may be valid. So there will be two paths from this. If it is error, then we have to display the error. So the result will be what? The error message. And here, this valid numbers will come, then it will compute the RMS. So the RMS value will come. So in this case, the result will be the RMS value. So so we can combine these two and say there is one bubble, one processing function. So this is a processing station. This is another processing station. This is another processing center. This is another processing center. Then you can have a level 2. So you can go to the this one, compute RMS 0.3. So you can break this now because these are very small, so you don't need to break. Like you can go to this and you can break it. Calculate take the valid numbers, calculate the squared sum, and then calculate the mean of it, and then you determine the mean square and then determine the root. Okay. So you first square it, sum it, determine the mean, and then take the mean square and determine the root of it. Now we come to the next one, that is data dictionary. So what is the question that we might be asked here? What is data dictionary? What is its benefit? So data dictionary is a catalog or a repository of system elements. What it will have, because everything that we write in our DFD has to be properly explained. So that is the repository we maintain. So in the previous one, all this data that we have written, valid numbers, squared sum, this processes. So all these things, the data flow. So we have the data flow, we have the data store, we have the processes with its identifier, name, description, properties, features. All these things are part of the data dictionary. It is a depository or a catalog. Just like we have library catalogs, we have data catalogs. What is its benefits? Why are we doing it? Why this is useful? Because It helps maintaining common meaning. It creates a consistency. Different users will not create different data names. If they create multiple data names, then there will be confusion. So they're standardized across the people and across the departments, both user as well as the system people. It can be used as a communication tool for locating errors, omissions, and when you have large systems, then the details are easier to manage, and it is helpful in documenting the systems such as properties, attributes, behaviors. So you can easily determine when you have created the data dictionary, later on when you are going to the design level, then you can get the attributes and the behavior. Facilitates analysis of a system in detail to suggest where and what features require modification. So later on, when you are in the management, in the maintenance phase, you can, or when you are developing it, you know where you need the modification because you have described your data and kept it in the repository. So what are the contents? The contents are the data description. Then you will have a structure, and then you will have a data flow, and you will have a data store. So when you have the description, you will have a name, and you can have some other if there has an alias, that means many different names. If it can be used as different names, what is its length? Well, what are the whether it has certain values or it can take any value. What is the type, the format? So these are like the modifiers. And then you have the data structure, whether it's a sequence relationship, selection relationship. So we'll look into this. We will take actually an example. What are these? So set of elements which are always included, sequence relationship, optional relation. So you have selected. That means you have a either or relation. Then repetition. That means set of data which will be repeated. So you have an iteration relationship and an optional relationship. Then you have the data flow. So data flow name, description, from to, those things have to be there. And data store. When you have a data store, you need a data name. Again, you have the inbound data flow, outbound data flow. What is the volume? What is the growth? So lots of information about the data store you can keep. And of course, the data structure. That means the record structure. Then last but not the least, you need to know the process. So for every process also, because it is part of the data dictionary. So there are 5 types of items that are stored in the data dictionary. And this is what I was telling, concatenation. This is equivalent. We'll take this example. Let's say student data. So if a student data is the data that we are describing, it will have a name and it will be concatenated by address. So that is the AND or the concatenation. This denotes a sequence. This way because synonymous. That means this student data is synonymous to this. It is equivalent to this, and this is the concatenation. Then you have a either or. That means if you have a data, if you can put either the land phone or the mobile, then you put it in a square bracket. And if you have iterations, then you put it in the curly bracket. That means course number, course name, course credit, multiple time it will come. So for each student, the student data will contain multiple course numbers. So because a student will take multiple courses, so this will be in iteration. Similarly, you can have optional. When you write, now you take this name to define it further. This name is equal to first name, middle name, last name. But everybody will not have a middle name, so it is optional. So you put the small bracket. What is the use of process specification? Now, so we have seen the data flow. 1 minute. So we have explained some of the questions in the data flow and the data dictionary. Next, we come to the process specification. So what is process specification? When we write the process, so every bubble that process has to be defined. Process we created for each of the bubble. We have to write that like a mini specification. Okay, so that we can design it. And it will contain these kind of things. It will contain some kind of a textual information. It will come some algorithm, maybe a sorting or some other algorithm. If it is an AI algorithm, it can be anything. And it can be some computation also. And there will be some mathematical equations or tables. You have to look up some tables and do some computations. Okay, and there may be some rules. And rules are normally given by decision tree or decision tables because they are easy to do. And there can be some diagrams or charts. So normally process specification will contain multiple items. Depending on the case, you will use one of it or many of it, multiple. Sometimes you use the program description language to describe the process specification. But normally at analysis stage, because now we are discussing analysis models, you don't use PDL. You use it during the design phase. So what is decision table? And what is it used for? Can you explain an example? So this is a example. So decision table is used to describe complex logic that depends on values of several conditions or events. So if you have a rule where there are certain conditions, and depending on that condition or a particular event, you have an outcome, then that means the result, the outcome, it depends on the value of the conditions. Then you can say that it's a complex logic and you can denote it as a decision table. It shows the rules for computing. So this is the example. We can take this example, create the decision table, which will give the rules for computing a discount to a customer. Under what circumstances a customer will get the discount. So it will have a combination of conditional values, and so let's look at the example. So on one side it will have conditions, whether there is an advance payment. So these are this is condition number 1, this is condition number 2, this is condition number 3, and this is action number 1, action number 2. So this is one way of writing the decision table. So advance payment is one condition. So you say, so since there are 3 conditions, you can have combinations of these. So Y means it is satisfied, no means it is not satisfied, or you can give a truth value, T and false, T and F. And if in this particular case, if the advance payment is there, then you give a discount 5%. Or if the advance payment is not there and the customer is a regular customer purchasing more than 10,000, then you have a discount. In all other combinations, you have no discount. You have 0 discount. So suppose you want to write this kind of complex logic, you want to put it in your software, then you can create a decision table like this. So you can understand how easy it is to do it. So then you have understood what is the use. It describes the complex logic, and you can take like this one example and you can explain it. This is another one. This is a slightly different way it is written. So there is an ID. So it is writing both condition and action. So here it is denoting whether it is a condition, and here it is denoting that it is an action. So this is for the ATM. Decision table shows different rules for transferring money in an ATM. So if the account is approved, the OTP is matched, balance is available, then you will get the money or you will transfer the money to some other account. But if balance is not available, or if OTP is not matching, or both are not there, or this is false, then you will either give an error message, that means no action is there. Here you are giving a message, or you will sometimes block the transaction also. So here you have no action, you are just rejecting that transaction, and here you are giving a this means that they are giving an alarm that this could be a fraud. So you will block the transaction. The action will depend on the truth value of the different conditions. Now the decision tree, this is a slightly different way of denoting the similar kind of things. So we will take the same example, same example of the discount. So here you have a bookstore and you have libraries and individuals. So here the size is, this is oversize. So order size is more than 50 and here it is less than 50. Then you don't give a discount. But if it is order size is greater than 50, 25%. And for libraries or individual members, if the order size is slightly less, then you give 5%, 6 to 19. If it is 20 to 49, then you give 10%. If it is more than 50, you give 15%. So the discount values are different. So if you have this kind of situation, either you can write it as a decision table or you can create a decision tree and say this. So at the end of it, these are the actions. At the end of it, the final leaf will be the actions, and on the root you start from the root, and each path will define a set of conditions. Similarly, there is one more here, decision tree for calculating shipping charges. Then we come to the control flow model, and when is it useful? Why do we do the control flow? Again, this is normally done in the structured analysis, not in the object-oriented analysis, when we do the flow-oriented procedures. And it produces control information. And because earlier in data flow, what we created is the information flow. We did not do the control information. So here we are trying to create a control information. It is similar. It is similar, not same, but similar to how we write the program flow in a flow chart. So in flow charts also we are showing the control flow of the program statements. So like that we are creating the control flow of the complete system. That is what we are doing, in addition to the data flow modeling. So along with the data flow modeling, we can also do some control flow modeling. So normally these kind of questions will not be asked, so we will just skip it. So this is one example of control flow model of powering fan with battery or power. So here there is so depending on the situation, the behavior will be different. So there will be different paths to it. So you can say if the battery is dead, then we can't give battery power. So we go to the normal power and put on the fan. Otherwise, if it is there, then we will try to take the power and switch from the battery to the power for powering the fan. And we also charge the battery with the generator and battery power to auxiliary device. This is more it will be more clear to you all because it is control flow of an ATM. It is more of an information system. The other one was a control system. This is more of an information system. So we had created the decision box for it. Now we are creating the control flow. Because in an ATM we are interacting with the ATM. So there is a machine and there is a person. So authenticate the account holder. So there can be so many paths. So not authenticated, fraud is possible. Then you will have include this release identification. And if it is authenticated, then you have a common flow. So this is the normal flow of the process. These are the exceptional flow of the process. So you have so here you are showing the control flow, how it is going. So this is the normal flow. Select the amount and then authorize the withdrawal and extension points, show balance. So there is an extension here. So show the balance and release the identification. So at the end of it, you release the identification and dispense the money. That means you close the transaction. So initially you look for the authentication, then you look for the amount, then you check the balance, and then you show the balance and do that. So this is the normal flow. So we are showing the normal flow, as well as we are also showing some of the exceptional flow. The control flow is being shown. At the end of it, it all comes to the end. Control specification, I will not like to spend any much time, because this is the behavior and we will look into it under the state diagram. Next class, we will look into the behavioral aspects of the analysis models, and we will go into the state diagram. So this is just an example I have given. You can just see it. These are the different states, and these are the events coming in, and there is a transition from one state to the other. A state diagram, sequential specification of a behavior, and you can also create a program. Nowadays we are not using this program activation table, so you can just forget it. Just for the completion I had written it. It describes the behavioral modeling. So now what we are basically doing is we are using the state transition diagram or state diagram as it is part of the UML, Unified Modeling Language, and it is now part of the behavioral modeling of the system. So as part of this, we will look at it. So this is just a diagram. So finally, we have come to the end of the system of the lecture, today's discussion, and this is all I had to show you and show you. So we have seen the analysis models. We have seen it in form of a question so that it will be easier for you to answer them. And as a principle, analysis examines the information domain. So we said what are the principles of the analysis domain. So we had explained this. I'm just looking at the chat to see if any of you have got any questions. So today I tried to put the lectures in terms of questions and answers. So I hope it is useful to all of you. And as you know, this topic is very useful for your, not only for your exam, but also for your interviews with your future jobs. So we have discussed the information domain, the functional and the behavioral. These are the principles. We have discussed the principles. We have discussed the two approaches, major approaches. That was one of our questions, the structural approach and the object-oriented approach. And we have seen what is OOAD, what is SSAD, why OOAD is preferred. That was another question that we answered. What were the elements? So we have seen that there are 4 types of elements. And for each element, type of element, we have seen what were the diagrams or the tools inside it. So also we have seen that the structural elements use these kind of diagrams, and the object-oriented uses slightly different kind of diagrams. And we went to the class modeling because that is very important for all of you. Mostly you will be doing the class modeling, but you must remember that even if you do the object-oriented approach in the class modeling, still you might do the DFD, data flow diagram, and the processing, and also the process narratives, the decision model and the decision tree, because they are part of the logic, the computational rules that you have to write. So in the class modeling, we have seen what are the types, how we will identify the class. Identifying the class is the major hurdle. Once you identify the class and you are able to tell what is its, define its attributes and its operations, then you can go to the design and then you can go to the implementation and write your code. But initially, when you don't know, then you just have a requirement with you, a very rough requirement, your use cases, that is at the inception phase, then you have to go to the grammatical parsing method or the CRC modeling method and do the analysis class. And once you have determined the analysis classes, then you have to find what are its collaborating classes, and you have to determine the class relations with the collaborators. So this we did not discuss because this is an implementation. I left it out. The relations are is a, has a, and uses a. Is a is your is having a knowledge. Has a, it means it's a part aggregate kind of thing, and uses a means it is more of a generalization and specification. So that's it. Thank you. If you have any doubts, I don't see any specific doubts in your chats. So since I am not seeing any specific questions, they are only generic questions. You can, if you want, you can send these questions in the next class also. Next class also will be on question based, so that it is easy for you to understand how you will prepare yourself for your exams. So thank you all, and we will end the session here.